Um, Viewers, you are welcome to my YouTube channel, Mathematics Made Easy. So in today's video, we'll be looking into the integral of the product law function. So firstly, before I get started, don't forget to subscribe to my channel, like my videos, and subscribe and share. Alright, so I would like to introduce the product log or the Lambert's W function. Okay, so let's say you have the product log of u e raised to the power of u. So this is going to give you u. You have a function u multiplied by e raised to the power of u. Then if you take the product log of it, you are going to get u. So don't forget that. Then so we can now make a substitution from this integral. You know, we have integral omega of x dx. So we can say put x to be equal to u e raised to the power of u, then you are differentiating, we are going to differentiate. So we are now working with respect to u, that is in u word now, from x to u. Then if you differentiate x, so that will be dx. If you differentiate u e raised to the power of u, you know, if you differentiate u, that is 1 times e raised to the power of u, e raised to the power of u, plus. If you differentiate e raised to the power of u, that's e raised to the power of u, multiplied by u, e raised to the power of u, du. Okay, so then our integral becomes omega of x instead of x. So we have u multiplied by e raised to the power of u. Then instead of dx, we have e raised to the power of u plus u e raised to the power of u du. Okay. So next thing we have to do now from this property that I said if you have the product log of u e raised to the power of u, you are going to get u. So product of u e raised to the power of u, that's going to give us u. I'm going to have integral of u into bracket e raised to the power of u plus u e raised to the power of u du. So it's now easy to solve. You know, the integral is now very easy to solve. You can just apply linearity and expand. That will be integral of u times e raised to the power of u, that's e raised to the power of u du, plus integral of u times u, that's u squared. So we have u squared e raised to the power of u du. So we have to integral to solve. Okay, so we have to integral to solve. So we can call this A and call this B. You know something that is hard, very simple. Then integral of u e raised to the power of u du. How can we solve this? So we can use integration by parts. So if we use integration by parts, you know, your u and your dv. So this is our u and our dv is e raised to the power of u. That will be plus, minus, plus. So if I differentiate u, that will be 1. If I differentiate 1, that will be 0. If I differentiate if I integrate e raised to the power of u, that's e raised to the power of u. If I integrate e raised to the power of u, that's e raised to the power of u. So I'm going to have u multiply e raised to the power of u and minus 1 multiply e raised to the power of u. So I'm going to have, so this will be equal to u e raised to the power of u, then minus 1 times e raised to the power of u, that's minus e raised to the power of u plus c. So that's that. And the second integral over there, so which is integral of u squared e raised to the power of u du. So we can also use integration by parts. We can also use integration by parts. So if you use integration by parts, so you have your u, you have your dv. So we have u squared, we have e raised to the power of u. If you differentiate u squared, that's 2u. Forget plus, minus, plus. If you differentiate 2u, so that's going to give you 2. And if you differentiate it, that's going to give you 0. If you integrate e raised to the power of u, that's going to give e raised to the power of u, e raised to the power of u, e raised to the power of u throughout. Then you multiply, this will multiply this will multiply this, and this will multiply this. Okay? Then write this very well. So we have e raised to the power of u, e raised to the power of u, e raised to the power of u, e raised to the power of u. So, sorry, e raised to the power of u, e raised to the power of u, e raised to the power of u, e raised to the power of u. So this will multiply this will multiply this will multiply this. Okay? Then I'm going to have u squared e raised to the power of u minus 2u e raised to the power of u plus 2 e raised to the power of u, everything plus c. So that's the second integral. That's second integral. So we have this and this. We can just add the two answers together to know our value. So if you add the two answers together, the first one, which is u e raised to the power of u minus e raised to the power of u plus c, then plus the second one, u squared e raised to the power of u minus 2u e raised to the power of u plus 2 e raised to the power of u, everything plus c. Alright. So if you collect the like terms here, this is u e raised to the power of u minus 2u e raised to the power of u. That's going to give us minus u e raised to the power of u. And this e minus e raised to the power of u plus 2 e raised to the power of u, that is plus e raised to the power of u, then plus u squared e raised to the power of u plus c. You understand? So we can write this as u squared e raised to the power of u minus u e raised to the power of u plus e raised to the power of u, everything plus c. But don't forget, from the substitution we did, we said put x to be equal to u e raised to the power of u. Okay? So definitely this will be x. This will be x. But what will be the value of u squared and e raised to the power of u? Now don't forget, if you take the omega of both sides, so omega of x is equal to omega of u e raised to the power of u. So that is omega of x is equal to u. Don't forget. So that is the value of our u will be omega of x. Then we are going to have u, which is omega of x, so that will be omega of x squared multiplied by e raised to the power of omega of x minus, don't forget this one is x, plus e raised to the power of omega of x plus c. So next thing you have to do here is that, so this just be omega squared of x, e raised to the power of omega of x minus x plus e raised to the power of omega of x plus c. You can leave your answer like this is correct, but let me just write one property of the product law. If you have e raised to the power of product log of x, this is going to give you x over product log of x. Don't forget, so that's what it's going to give you. So e raised to the power of product log of x is going to give us x over product log of x. So I'm going to have product of x squared multiplied by x over product log of x minus x plus x over product log of x, everything plus c. Okay, so product of x is going to cancel when out here. So what are we going to have here? So that will be x. Let me write it at the top. So we are just going to have x multiplied by product log of x minus x plus x over product log of x, everything plus c. Now what do you notice here? We can see that x is common throughout. So we can factorize x out. That will be x into bracket product log of x minus 1 plus 1 over product log of x plus c. So that's the answer to the question. Therefore, integral of the product log of x dx will give us x into brackets product log of x minus 1 plus 1 over product log of x plus c. So that's the answer to the question. Please don't forget to subscribe to my channel, like my videos and share. Thank you.